Next is using homogeneous coordinates. So there's an easier way to deal with geometric transformation is using homogeneous coordinate based on this book. But I'm not sure it's really easier or not, but we just accept that we have a different way to deal with coordinate transformation, which is homogeneous coordinates. So what is homogeneous coordinates? So this is the definition. Every point with the Cartesian coordinates xy can be assigned the homogeneous coordinates tx, ty, and t. So conversely, given the homogeneous coordinates of point RST, we can determine its Cartesian coordinates by this formation. So in this case, we're going to assign this 2D point its homogeneous coordinates is x, y, and 1. And then we can represent the geometric transformation using this formula. So we have we can express the transformation using 3x3 matrices. So this is for rotation, this is for scaling, and this is for translation. Okay, and it depends on the order. If we want to follow a certain order, we can get certain result. So for example, if we will do translation first and rotation later and then scale later, we're gonna get different result with the rotation, scale, and translation. But I'm gonna talk about this in the next video. So in this video, I'm gonna focus on how to do the homogeneous coordinate transformation. So as we see from the previous example, we have the same example as this one here. So we are given 4 point, point 1, point 2, point 3, point 4, and we transform to, so from the red here, we transform to the green shape, which is point 1, prime 1, point P prime 2, 3, 4 here. So in order to follow this transformation, we need to know which is the order. So in order to do that, we run that, and we can see that here, 1 here is 0, 0, and after transform, this is 3 and 2, but here we got 1.4 and kind of 3.5. It's not correct. Why? Because we chose the order of transformation is not correct. So now, how can we change the order of transformation? So I think the order of scale and rotation doesn't matter, but the order of transition is very important. So let me do a so we want to follow and have exactly this result. We need to change this to t here, and also this is t here, t here, and t here, and we delete this. So we see that 0 now become the output of 0, 0 is 3, 2. The output of 1, 0 is this one, 4 and 3, nearly 4 and 3. Yeah. And that the output of 1, 1 now is 3 and nearly 4, 3 and nearly 4 here. So why does this happen? So here we're going to choose the rotation first, then scaling, and then do translation. So let's try a matrix. We're going to do the scale first and rotation later. Let's see how it works. Scale first and rotation later. So that means we will scale, and then we rotate, and then we do translation finally. And if we can see that, it's pretty much the same. So we save the result here. We got it 3, 2. So now we get back to this is SR, 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 SR. We get back to here and we get the result looks like that. So we can see that actually the order is very important, and it actually influences the result. So we need to choose the order very carefully. So based on this formula, we can see that the order is rotation, and then scale, and then translation. Okay, so we should choose rotation first and scale, and then translation last. So we go for rotation, scale, and translation. And we have this. Okay, we have this, we can copy and paste down here just for comparison. Okay, so this is the result using 2D transformation matrix. So let's try to use different approach, which is homogeneous coordinates. So in homogeneous coordinates, we need to define the transformation matrix as 3 by 3 matrices. And here we have the same input, it has the same rotation angle, the same scaling factor, and the same transition values. We define the transition matrix looks like this, similar to this formation. We define the scaling matrix look like this, which is exactly this one. And we define the rotation matrix look like this. Okay, so now it's very important the order, because we know that the order is here. Rotation first, so we're going to choose rotation here. Then scaling, we choose scaling. And finally is transition, and we choose transition. And then we run it using homogeneous coordinates approach here. And now we can check the result, and we can compare. Let's delete some unnecessary thing. So now we can compare the result. So after run that, we have the first point now become this GG4. The second point now become this and this. So it seems like something wrong here. I know. Okay, so we can see that we found the problem. Here we just define you want to do for 2, 3, and 4. And then it needs to be 2, 3, and 4. And let's run this again. So you see that after we run that, we can see the result using homogeneous coordinates is the same as using 2 by 2 rotation matrix approaches. And that's it for using homogeneous coordinates transformation approach to transform 2D Cartesian coordinates from the red shape to the green shape.